This conference is brought to you by CallStack, your React and React Native development experts.
Hello everyone, welcome, and welcome everyone online watching live as well. We will talk about, which started very quickly. It is in my pocket, but anyway, cpp.js.org, that's our website. We claim to have complete toolset for C++ to JavaScript, and it means a lot of things because a lot of people also claim similar things, I think, that we keep seeing and we try to compare. But here you will see a different style and architecture that is designed for C++ developers who knows nothing about React Native, nothing about WebAssembly, just like old-fashioned C++ developers. We integrate, bring them into the ecosystem of mobile and web. So we will look into what CPPJS is and directly jump into creating new sample projects, some Hello World example, object-oriented programming support, and then how we compile them to web and mobile. Then we will see our tool sets that we did make available and published online, open source, and that's our ecosystem. Then we will see how you can use existing libraries, C++ libraries that we ported already, and you can port your own libraries, like no custom or extra code. And there's no learning curve, just one button click, you can port nearly everything from C++ 11 and 14. And we will see, we had from CallStack really great ideas and feedback. We will show how a potential hiking app would work. We will see how you could compile and use zlib and some performance nodes, and we will finish there. So what we know is that C++, the language and the whole ecosystem has been around for decades, and we have a lot of libraries, this box, little one. And we have the QR code with the GitHub page that if you give us stars, we celebrate every single star because we don't have much yet. And I will be very, very happy if you do that. I think I'll show the QR code one more time. And on the JavaScript side, we have all the agility, capacity, and that it works everywhere now. And decades ago, C++ had similar claims as well, like it would work everywhere. And now we want to bring all these existing computational abilities and performance features, let's say, to React Native ecosystem and WebAssembly. And the goal was not only like to have like simple C++ applications, but to create something sustainable, scalable, enterprise-ready, with low maintenance, low cost, that you can repeat and you can trust the process. And that works for WASM, the web world, and also the React Native in the same way. That one single solution, and what we say is that you write all your application logic as usual, C++ code. You don't have to know anything about that or other stuff, then your UI with React Native. And we handle the rest. So John is my neighbor, that's a real story. He's familiar with C++, and one morning he came, he said, oh, look, I'm learning React Native and I'm learning this and that and that. And then weeks passed, he realized like he's not learning. It was really difficult to bring his own programming experiences into web and mobile because he had a really cool idea of like indexing files, etc. And he needed a nice user interface. But his user interface was not matching his knowledge of backend. And so today in the talk, what you will see is that three things to go home with. Beginner users, you will be able to write normal C++ code that runs in JavaScript, seamless, nothing extra needed. And some other guys interested in using libraries that you will be able to just import any of the libraries from our repository. Or if you're experienced in C++ and expert of some of the libraries existing, then you could technically contribute into our repository and start compiling your own libraries. And this is how you start. npm create cpp.js latest, and that will handle everything. It takes time first time because we have tons of tools behind already, like for every architecture, for all the Docker images and everything automated. So first time installation will take little time, 5-10 minutes, depending on your internet connection, but then everything is super nice. You could say new project, and you will get instantly web, mobile, backend, cloud, and library options. Nearly about 12 sample projects to begin with that you can instantly compile, and they are like ready templates for you. If you say mobile, it will tell you React Native, and then you have Expo option or native CLI. From the web, you have vanilla option, just anything you want to use in JS, or React Vue, Svelte. We are not only React Native solution, by the way, so we just support any environment. And so we have everything. And then for the web, we would have all other bundlers as well. And for packaging all the code and resources. In the mobile option, you have iOS and Android options that will trigger Xcode and Android toolsets, and then run in emulator, simulator, or like natively in the devices. Then in backend, you can run server applications with your C++ code, and in cloud, you can write Cloudflare workers, and the single code base will ship into everything with single click, and they will be all compatible. Then with the pre-built, you have one sample project, source is just header-only files that you don't compile, you can just include and call, and one CMake example as well there. So Hello World is as simple as it gets because it is just a pure C++ code. You have it, and you would see little differences that the header file is included in JavaScript, and normally there's nothing about it, right? That we have a tool for that to be imported. And then this await init CPPJS is the one-line code that you wait for tools to get ready and the whole process runs, and then you call all the C++ functions or create new objects, run the constructors, everything then is available inside JavaScript, and we handle the rest. And we will see how these things run. And plus, imagine, like when everything is happening, it is gonna have all the object-oriented programming support for you and ship into all platforms available. And we would love to have feedback because I know a lot of experts in this room, and if you tell us, hey, I know this similar tool, or oh, we do similar things, any suggestions, we are really excited to hear. So the full automation and how it works. Look at this class, a sample class that we simply wrote in C++, and here is the implementation. And now the question is, how does this JavaScript code understands what is going on here and how do they call each other? If you see new factorial and do not put 99,000, that doesn't exist, put 10 for those who doesn't listen to the talk. And when you call these functions, it will completely go. And then for bridging these two code, we have this first tool, CPPJS binary, which is actually a JavaScript application, about 2,000 line of code. This is doing just putting these all tools and code together. It is actually calling a bunch of other tools. And what it does initially is that sits in between and takes the header file, firstly for you, and creates a Swig interface. Some of you will know Swig, and Swig said they don't want to have mbind support, and you will know mbind from mscripten. So we did that, and we built one tool, but Swig doesn't take the header file, so we did the tool which creates an interface that Swig can understand. And we take then this interface created, it's going a little faster, but we have the Swig bind tool, which is about 700 line of C code, which is to create the interface, which is actually a C++ code. So from the Swig compatible interface that we first generate, then we also, with our tool, generate this Swig runtime binder. And that's the connection, basically, where JavaScript makes sense in C++. And then we have another tool we developed called mscripten plus. Because mscripten doesn't support CPP function overloading, we did that. It's a very small fork, so it's actually same as mscripten. And right now we are compiling for WASM and web, so we are not doing mobile yet. We will do web in a second. And you will see how similar the process is. We take the bindings and put into mscripten plus, and put the header file and get the WASM JS output. This is pretty much similar to or less work than the whole process. Then when we do the same thing for the mobile, we will see the similar step. Remember, Civic bind prepared all the interface for you. And these mbind syntax now does not work in JSI. And that's the challenge. So in the mobile world, there is no meaning of this. And what we did is then JSI++ tool, which is another tool which is making mbind compatible with JSI. And that's about 5,000 line of JavaScript code and another 5,000 of C code, and which does the process of making JavaScript understandable in C++ and vice versa. And what happens there is we have Android NDK and Xcode for mobile to compile all the binary together, and you take the source code again, give it the runtime binder, and you get the mobile libraries. So this is the native binary running on ARM64. We support 64-bit only, not 32. And so ARM64 and simulator x86 64. And then, you get the library, and from JavaScript, as usual, you can then call the libraries. Then the question is there, how does the header work then? For header to make sense and to be imported, we have these bundlers. So we cover maybe 90% of what available bundlers are, because we tried to write every plugin necessary so that every project could just run and people don't have to learn new things. So our bundlers will handle the communication between. And what we did is already 15 libraries are available. These are already ported. Right now you can import and single-click start using. And some of with the logos, the total list is here, and we have SQLite here, and we were talking with Richard, and it was really a big pleasure, having him here and talking about how we use, because it was because of the license actually, because it was completely open and in public domain to use, so we tried to use anything possible initially. And so the total, this is the total ecosystem that we have, and we have a few dependencies. So 4 tools we made: CPPJS, MScript+, Civic bind, and JSI++, then all the bundlers, and we target all these platforms with the same code base, and you get the product out. And so this is another graph of how everything puts together. You have the JS and C++ code on top, with all the libraries already compiled in our repository, available to be imported. CPPJS uses all the Docker images and all other prepared tools for you to create the first interface. Then interface is being created with the CPPJS, this runtime Civic binder, and then the same binder going into JSI and MScript. And the nice thing is here, with the JSI, let's say, conversion or the bridge, we don't have any fancy or high overheads because we are using everything how MScript is handling. Instead of WASM taking the commands, JSI takes that. So the whole process is pretty much standard. We didn't invent anything new. The whole syntaxes are basically standards in the among the developers. So that's should be very similar to what everyone knows. And then people get the outputs. In our website, we have the showcase of packages available and a few running applications with GDAL and Cartomobile. So you could run all these heavy simulations natively on your devices and web. And we will see a few more practical stuff. This is an example that if someone going on a hike and having a DEM files, digital elevation model, which is gigabytes of data, and offline querying is necessary because you're in a mountain or a low altitude place, and there are almost no native frameworks in iOS and Android that you could have one single code base, and you have to parse this GeoTIFF DEM files and process them. And you need performance, surely, if the file is big, and also you want to do it as easy as possible. What you could do without learning anything new, you could write your own code for querying all these libraries in C++, nothing new, just whatever you want and whatever runs in normally on your desktop application. Then with one line of code, import GDAL, and then all the functions are available for you. That all of the C++ code will just compile and work. And you could still have all the other dependencies, nested usages, and all the dependencies and everything will be resolved automatically as well. And there are a lot of other little skills that we will not cover in the presentation, but hopefully in the future I'll show, because we had some optimizations. And other one is using zlib in web and mobile. Normally, if you want to use the library functions, you could use flate or Paco, some pure JS options. Otherwise, you have to port the native library. And if you do that, there are two ways. You can do by yourself, go with the manual efforts, or use our library, import directly. And the thing is, if you do with the manual effort, you have to, maybe you could use the native browser APIs, or you have to continue manually with a lot of stuff. I'll not go into every detail, but in iOS, Android, you have a different process to do, and write the wrappers, bridges, and etc., etc. And there is no one standard way of doing these. And in general, you don't have object-oriented programming support. In zlib, I think you don't need anyway, but you could go all these efforts, and the thing is, later, it is really difficult to maintain. And the question is, can you give long-term support to your manual work that you had done? Or the technical depth you would be thinking on, enterprise settings. Instead, what you can do, again, npm install CPPJS package zlib, and then the zlib is available. And in practice, what you do is you have to create one config file for your app and enable the library with the first line, import zlib, and then say the dependency. And that's all you do, basically. Next, you can start using, oops, I'll go one back. So with a new file created, you can put the zlib header, native sample, a class and function, and you are using native functions of zlib there, and it is available in JavaScript. You're just using this native, just the file you created, you import that, and you can keep running these zlib functions. Runs on all platforms. Next, if you were to compile zlib from scratch, let's say it's not available, it's a new library you need, and you want to compile. What you do is put the repository link, the original source code there, in a CPPJS build file. You create build file, and also a config file. Standard templates. You don't have to learn anything, it comes with it. Or you just change the link, basically. And then the next thing you do, put the version you want to compile. And that native version line, the first version is the npm version for the metadata. And then the build command, cppjs build, is the one you will run from terminal, and it will give you output of all these, all platforms. And when you're using, it's the same thing before, zlib available for the config.js, that's for the app, and then you start putting your source files, and everything is ready again. Remember the box we had there, and there are a lot of famous libraries we are trying to port. We try to bring more, and we did 15 of them, but our goal is to include more and more libraries, make them available in React Native and other platforms. And if you're an expert of a library, we have an email address, new-lib@cppjs.com, that if you want to help us, we would welcome, because there are a lot of opportunities with it. We are two people, Buğra and I, and we would love to connect with you. And this is, again, our GitHub star QR code. I believe this will go to this link. And if you want to join, because there's a lot of space in the team, this could be you, you could enjoy having, oops, I'm going fast for some reason. And Korhan also contributed to our project, so big thanks to him. And I think Buğra and Korhan now watching from Ankara live on YouTube, so thanks guys for all your work. And he's a great developer as well, Korhan to follow. So few notes and I will finish. Here is almost the same code written in JavaScript and C++. And if you compare the performance, naturally you get all the benefits, that 2 times, 4 times, because it is native code, native binary running on the hardware. And again, fast, but so benchmark notes. So that some people say, hey, but what is your benchmark on the bridge you created? We literally matched the performance of mscripten because we didn't introduce anything new there. So all the implementation, no extra overhead, existing overheads basically. And for passing the data, primitive types are copied, but they are not big. All objects are shared with the pointers, and we have the same performance, basically. And then we support C++ and above. If these are usual stuff, basically, if there are functions returning pointers, you have to manually handle that, add a few wrappers around that when you enter or exit. And if there is some objects to be cleaned, and if they are not, again, you have to do it yourself. And one debug tip, because we recently saw, and I wanted to add, there is this CPPJS folder in the project directory that if sometimes when you change the code and if it is not recognized, just delete it and recompile. For questions, we are available. This is our website, cpp.js.org, and that's all. Thank you, guys.